Have you ever wondered why some wires get hot easily, why some don't? Or why some wires allow current to flow easily, why some resist? In our previous lesson, we talked about Ohm's law, which tells us that resistance of a conductor affects the flow of current. In this lesson today, we are going to look at those factors that affect the flow of current or that affect the resistance of a conductor. Understanding these factors will help us to choose the right wires, avoid or prevent overheating, and also solve some physics exam questions. Factors that affect the resistance of a conductor or electrical resistance. Number one is nature, the nature of material, or we call it type of material. Now, these different material have different numbers of free electrons. Now, those material with many free electrons allow current to flow easily because those ones they have low resistance. Now, those material with low free electrons have high resistance. Then number two is the length of the conductor. Now, length of a conductor, resistance of a conductor is directly proportional to the length. That means that it varies directly to the what? To the length. It means that as the length of a conductor increases, the resistance also increases. For instance, if you have two conductors of different length but the same thickness, notice that the one that is the longer conductor have more resistance than the short. So here you see that resistance varies directly as length. Then the next thing is cross-sectional area. That is thickness. You can call it thickness. Now, the thickness here, it means that the resistance of a conductor varies inversely as the area. So here it means that as the cable, the thicker cable have ability to allow more current to flow, whereas the thin cable will not allow such current to flow. For instance, if you have two cables of the same length but different thickness, for instance, you have a cable, this one is 1.5 mm square, this one is 4.5 mm square, but they are of the same length. Now the thicker one, the one of 4 mm square, has low resistance, and with this it will allow more current to flow through it. Then the next thing is the temperature. Temperature has in metal, in a metallic conductor, in metal, when as the temperature increases, the resistance increases as well. That means that the resistance is directly proportional to the temperature. This is when you are talking of for metallic conductor. But in semiconductor, the temperature, as the temperature increases, the resistance decreases. It means that resistance varies inversely as temperature in the semiconductor. All right. Now, if you bring this formula together, remember this property of the property of this material we are talking about is known as resistivity. Resistivity, this is the symbol, is the property of this material, the material by which the conductor is made of. Now, if you bring this together, like I said, that the resistance is directly proportional to the length and inversely proportional to the area. Now, by the time you bring this together, you notice that here, you have here that the resistance varies directly as length and inversely as what? The area or the thickness. Now, for you to remove this sign of proportionality, here means that R, being the resistance, is equal to the resistivity, which is the property of that material, multiplied by length all over area. Now, the resistivity here is measured in ohmmeter. How do you get that? Now, if you make this the subject of the formula, here you will have that. Let me break it down. I will write up that same formula. Let me break it down here. Now you have here that R is equal to resistivity times length all over area. Now you are looking for this. I want to show you how you get the unit of this, because here I told you in our previous lesson that resistance is measured in ohms. Then length, of course, you know that length is measured in meters. Then area is measured in meter square. So look at the unit of these variables that we have here. Now, for you to get the unit of this resistivity, now you make it the subject of the formula. By the time you make it the subject of the formula, what you have here is that resistivity is equal to resistance multiplied by area all over length. And then you have this. Now, what is the unit? Let's look at this. What is the unit of resistance? Now, the unit of resistance is what? Ohms. What is the unit of area here? The unit of area is meter square. Now, all over the unit of length here is what? Meter. So this cancels this out, and you are left with what? Meter. Meter. That is the unit of resistivity. Then for more physics made easy, you need to follow, like, subscribe and to this channel and share.